Okay guys, back with Module 2. We were just talking about ECG paper, the speed at which it runs, 25 millimeters per second is the standard speed. And it's also the speed which we see going across a CRT or flat panel screen. If you watch TV, you see these hospital shows on there and you see an ECG monitor, a heart rate monitor, whatever you want to call it, and you see a trace that's going across that. They're traveling at 25 millimeters per second. The next thing we're going to talk about is how to analyze an ECG. And it's actually a 5-step process. I want you to understand these 5 steps. The first one is we calculate rate. How many times per minute does the heart beat? And then the second thing we do is determine regularity. And when we talk about regularity, we're talking about, is this the same distance from here to here as it is from here to here? Is this the same distance between these two as these two? In other words, we compare all of the heartbeats, and obviously each one of these is an individual heartbeat. We compare each one to the other and the distance between them to make sure that it's happening at a regular rate. It doesn't always happen that way, but it is something we need to take into consideration to determine if this heartbeat is what it should be or not. In step 3, assess the P waves. We're going to look at the P waves. We'll start breaking this thing down now into its component parts. And you remember what the P wave is. Each QRS or each ECG complex should have a P wave associated with it. I see the trailing edge of one over here. I see one here, 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 here. So we see a P wave for each one of these complexes. So it's actually several parts to assessing the P wave. We'll get, I think in the next module we'll see what that's all about. But for right now, just look and make sure that there is a P wave with each one of them. Then determine the PR interval. How wide is this? How long is it from the beginning of the P wave to the beginning of the QRS wave? Basically is what we're looking at here. You can't really see probably in the video. You can see these big boxes, but you can't see the little blocks inside of that. There's 5 little blocks inside of the big block. We're going to measure the width of this by counting those little blocks. Each one of them represents a time, and we'll talk about that too. As a matter of fact, we need to know that same information for determining the QRS duration, because the next thing, step 5, is we're going to look at the width of this. How wide is this QRS? And again, we have to be able to count the small blocks in here to know how much time it's actually taking for that to happen. Okay, back to our strip, our 6-second strip that we said earlier. This is not really super accurate, but it's a quick way of determining what a rate is. So basically, we know that 6 seconds of time is 1/10 of a minute. If we wanted to know what the heart rate was, number of beats per minute, then we could count how many heartbeats actually happen in 6 seconds and just multiply times 10. So that's what they're teaching us here. So we count these 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, it's not highly accurate, but 9 times 10 is obviously 90. By the way, think about that number now, 90 beats per minute. Does that fall within the normal range of the SA node firing? Usually between 60 and 100. Yes, it does. So that should tell you something about the answer to step 1 on this, which is this a normal rate? Yes, it is. It's normal because it falls between 60 and 100. And here we see at the bottom, I don't know if you can see it or make it out or not, but 9 times 10 equals 90, which means that this is normal. Okay? So we've calculated the rate. There is another way of doing it by looking at the small blocks and doing some stuff. Don't worry about that. This is just this is how we're going to do it for right now. Okay, the second thing is determine regularity. Again, what we're looking at is basically it's the same amount of time between each one of these QRS waves, or the R waves. Yes, it is. Actually, with experience, you'll be able to glance at it and see that it is. I can glance at it and tell you that yes, that is normal, and it's regular. And the nurses and the doctors do the same thing. And even if it varies just a little bit, it's not a big deal. But I'm telling you, they can glance at it and tell you, and you will be able to do that as well. So look at the R to R distances. It says use a caliper or some other means, but a caliper is just a thing that you just spread out, and you would place it like this and then move it over here to there and just verify that they're all the same distance. Again, you don't have to do that. You can glance at it and tell. Are they equidistant apart? If they are, it's considered to be regular. And you'll see these terms too: occasionally irregular, regularly irregular, and irregularly irregular. Don't worry about that. It's either, for our purposes, it's either regular or irregular. Interpretation here is, this is regular. Okay, step 3, assess the P waves. I said there's actually more to it than just looking at them and make sure they're there. The first step is, yeah, we look at them. Is there a P wave there? Yes, there is. That answers that part of the question. But we also have to ask, do the P waves all look alike? Well, I can tell you, if you get up to this and you look at it real closely, they're not all exactly alike, but that's okay. Are they similar is probably a better way of asking this question. Because there's going to be, even if they were generated the same, there's going to be differences in the way they're displayed. So the answer to this question on this particular strip is, yes, they all look alike. Do the P waves occur at a regular rate? Just like we measured the distance between the R to R intervals earlier for regularity, we're going to do the same with the P waves. Here, here, here. Are they all regular? Yes, in this case they are. And is there one P wave for every QRS? We know that the P wave is generated by the sinoatrial node, which causes the signal to start, which then goes all the way through the heart and generates this whole complex. So if we know that, it stands to reason that if you had a QRS, it should have been generated as a result of the SA node firing, which is represented by the P wave, but that's not always the case. Remember, just a few slides ago we said the ventricles have the ability to pace themselves. So if they don't see this signal, they can actually do their own thing. But that shows up a little bit differently. We'll talk about that more later too. But the question is there one P wave for each QRS? At this point, we're just going to make sure. Yeah, satisfies that. So that all is normal. So that's how we assess P waves. Interpretation, normal P waves with one P wave for every QRS. Step 4, determine the PR interval. We're going to measure how wide is this right here, okay? Remember what the PR interval is all about. Normally it will take 120 to 200 milliseconds for that to take place, which is, I think, 2 or 3 or 4 of those small boxes, I'm not sure. 3 to 5. It says 3 to 5 boxes of small boxes. Interpretation in this case, it's about 120 milliseconds, which falls at the lower end of normal, so it is considered normal. And then the last thing is QRS duration. Basically, we're going to measure the width of the QRS here. How wide is that QRS? That's very, very, very important. Normally, it's between 40 and 120 milliseconds. And we can see that each one of these here, they're saying is about, well, it says anywhere between 1 to 3 of the small boxes. In this case, they're about 2 boxes wide, which is 80 milliseconds. So this would be considered normal as well. So in summary, we're saying in this particular case, just on this strip, have a normal rate between 60 and 100. The regular intervals for the QRS, P waves are there and they're normal. PR interval is normal. The QRS duration, or if you prefer the width of the QRS, is normal. So, interpretation, normal sinus rhythm. Now let's look at this. We said earlier that this is very descriptive. I want you to understand this. It is normal sinus rhythm, and it's normal sinus rhythm because, first of all, it's rhythmic. It happens over and over and over and over. So that's the rhythm part of it. It's normal because it satisfies all of these things. Normal range, normal width, all those things are normal. What does the sinus mean? It has nothing to do with your sinuses or your nose or anything like that. The word sinus is in here because it indicates that this signal, all of these signals, originated in the SA node, the sinoatrial node. So when we say something is sinus in terms of the ECG, well, all we're saying is the signal originated in the sinoatrial node. Very important thing to keep in mind, because we'll see that a lot going forward. Okay, that's it for this one, guys. We've got one more to show you.